Okay, so we give this function here, ax squared plus bx minus 3, and we're told that it has the value 11 when x equals 2, and we're told that the minimum value is when x equals minus 3/4. Oh, and we're also told that a is greater than 0. And so our job is to find a and b. Okay, so let's do a little bit of a sketch first, because I always like to do this to see what we're up with and what we're working with. So we know the value is 11 when x equals 2, so let's hit the point 2, 11, somewhere up here. And we know that the minimum value is when x equals minus 3/4. So let's say it's somewhere down here we've got some sort of minimum. We don't know what the minimum value is, but we know it's there. We also know it's a quadratic function and a is greater than 0, so it's kind of curving up like that. Okay, so we don't know exactly what that is, but let's do that as a bit of a sketch. So we're to find a and b. Right, so what are the bits of information? So there's two unknowns, a and b, and there's two bits of information that we're given, that one and that one. So we should be able to figure it out. So the first thing I think we should do is make use of this bit of information, that the point 2, 11 fits on the curve, so that we know that if f of x is ax squared plus bx minus 3, then we know that 11 equals a times 2 squared plus b times 2 minus 3. And what's that? 4a plus 2b minus 3. Take the 3 across the other side. 14 equals 4a plus 2b. Divide everything by 2. 7 equals 2a plus b. And let's just isolate b. b equals 7 minus 2a. Now, the second bit of information we've given is the minimum value is when x equals minus 3/4. Now, the minimum value, which is here, is when the tangent is flat, or in other words, when the derivative is 0. So if we were to differentiate that function, ax squared plus bx, take 3, we get 2ax plus b plus 0. Okay, and we know that's equal to 0 when x is equal to minus 3/4. Okay, so let's just multiply that out. So minus 3a over 2 plus b. Move this over to the other side, so we get b equals 3a over 2. Okay, so we've got b equals 7 minus 2a, and b equals 3a over 2, so we can make those things equal. So 3a over 2 equals 7 minus 2a. What am I going to do? Multiply both sides by 2. Just to get rid of the fraction, so 3a equals 14 minus 4a, and bring this 4a to the other side. 7a equals 14, therefore a equals 2. Take that a equals 2 and plug it back into here, and we get 3 times 2 is 6, over 2 is 3, so we get b equals 3. Just as a safety check, plug it back into here, and we get 7 minus 4 is 3, so that's the answer. A equals 2, B equals 3. Okay, so that's good enough. We could stop there if we wanted to, and that would be fine. If you want to do another check, then we'd go back to the original function, and let's do the substitute just to check that it works. So this is optional, but you'd go f of x equals, what have we got now? 2x squared plus 3x minus 3, and the derivative is 2 times a, so that's 4x plus 3. Okay, so we're told that 2, 11 fits on the curve. Let's see if that's right. So 2 times 4 is 8, plus 6 is 14, minus 3 is 11. That's right. And we're also told for the derivative that is minus 3/4 and 0. So minus 3/4 times 4 is just minus 3, plus 3 is 0. Yep, we're right.